Hi, everyone. Thanks for joining us today on the Learning Hub from BLAST. So I'm Todd from BLAST, and I work with math instruction right now. And I'd like to show you today a little bit about the technique called Notice and Wonder by Annie Fetter. So I have our slides up. Let me get that ready. And so what I want to talk about really is strengthening your math instruction. We do a lot of things in math. We cover a lot of content. We cover a lot of algorithms, but we also need to keep in mind good math instructional practice when we go through our lessons. And part of the reason I want to talk about that just a little bit is that we have to understand it in our classrooms. It is part of a whole or bigger picture. And if we look at the MTSS structure, it guides us through what good instruction may look like at different tiers and meeting different needs of students. So in tier 1, we have instructional practices that all kids get. You know, that's just what we deliver in our classroom, whole class. If we do choral responding, everyone gets a shot at choral responding. If we do practice problems on the board, everyone gets a chance at doing practice problems on the board. But what we know is not everyone learns at the same pace or the same rate. And so for about 80% of our students, that first round of our instruction is going to be very worthwhile, and they'll understand what we're talking about and what we're teaching them. But for about 20%, that may not be the case. And so that's when we would, or I'm sorry, 15%, that's when we would look at a tier 2. And so those are the students that we may have to find some small group time, some pull aside time, and really strengthen a little bit what little part of the concept didn't they get. Maybe they missed part of the process or a few steps, or they didn't quite understand what numerator and denominator meant, and in whole class they got lost. Well, maybe in a small group we can kind of strengthen that understanding, give them some specific examples, and then they're good to go. And out of that group of kids though, out of that 15% of kids, there's still maybe 5% of them that really are not understanding what we're covering right now. And they may need help with some very core foundational skills. Maybe we discover that they have a lack of understanding basic math facts. Maybe it's something behavioral. In one of our districts, we found out that one of the kids who was assessing poorly had a fixation about having his numbers perfectly written and would spend a lot of time on his assessments erasing and rewriting his numbers if he didn't think they were perfect. And so we kind of had to do some behavioral intervention with him and say, it's okay, write your numbers the first time, and when the assessment is over, you can gladly go back and fix or rewrite any of the numbers that you think need to be done differently. And so really in that tier 3, we start to hone in on what exactly do these few students really need to keep them moving towards achievement and their math goals. The issue is, whoops, sorry, let me change the slide. The issue is that if we don't have a strong foundation in tier 1, if our instructional practices aren't really based on research and foundational experience or foundations and experience in our classrooms that we can see and monitor growth, then the information that we're getting for tier 2 and tier 3 is really a little shaky, right? So if a foundation of our house, our instructional building, isn't really strong, then the tiers above that foundation are also going to be weak. So oftentimes what we might find is that we think a child is not understanding a concept when really we might own part of that percentage, and maybe we have to change our instructional delivery a little bit, or just change the way we're having a discussion in math class, the way we're presenting an example. You know, UDL is a great example of that they're looking at, you know, are there different ways we can present information? What different ways are we able to receive what that student knows? And what kind of ways or means can we put into the student's hands that help them goal set and know what their specific learning criteria is? So it all really comes down to, you know, we have to start somewhere, and that starting somewhere is really with tier 1. And so today what we want to do is look at one of those strategies that might help. When we look at learning, as I drew in the slide, if some of you may recognize that as a number bond graphic, but we have learning, and then the two components of learning are always going to be student and instruction. And we as teachers are involved with the responsibility of that instruction. Sometimes the student and instructional circles change size. Sometimes it's very open-ended and very student-heavy on the responsibility for learning and making inferences. Other times, maybe in the beginning of some lessons, the instruction and teacher side of that circle is very large because we're delivering a lot of new content. We're making some of those connections to help them out. So those two circles always are working in harmony and in balance to create that aspect called learning. So for tier 1, we have to make sure that our circle of instruction and delivering that instruction is very strong. When we do notice and wonder, we're looking at also the math practices. So we've been told and given information on how to deliver content, but we also have to look at the instructional practice of math, and this is where the math practices come in. And so there are 8 math practices that we should be aware of. Math practice 1, making sense of problems and persevere in solving them, is very important. We have to have kids know the strategy and know the thinking process that doesn't put up the wall when they come up to a tough problem. You know, part of perseverance is I have some strategies that I know how to get through the tough hike. I know how to manage my way through the rough trail because I have strategies to work through. But if we don't give kids practice in struggling a little bit with what they call productive struggle and allowing them to know what it's like to think mathematically and think in the way of problem solving, then if they get to a hard problem, they may just stop and then not go on any further. So part of that math practice 1 is really teaching perseverance and understanding that it's okay to try different things. But the part is you try, you evaluate, and then you repeat until you get to some level of success. And the other math practices are there. You can look at those. And what we want to concentrate on, though, today is with that notice and wonder strategy, what math practices are we actually connecting to? We're looking at math practice number 1 to make sense of problems and persevere in solving them. And so we're going to give kids a pretty open-ended problem or some problem that has a lot of information missing in some respects. And we're going to say to them, like, I want you to figure out, what do you already know? And what might this be? You know, we're going to help them contextualize the task at hand rather than just looking for numbers to plug and chug into the information or come up with some kind of an answer. We're going to look for and express regularity and repeated reasoning. And so if I see patterns in this thing called math, and if I see some reasoning in this structure, will that carry over to similar structures? So we want kids to start to have that connective thinking, that flexible thinking, that if it works here, will part of it also work in this problem and in this task? And so with notice and wonder, we start to have part of the wondering or the questioning is, given a similar problem, will it have the same result in a solution? We have to give kids practice in thinking those things through. And then attend to precision in the use of learned vocabulary. I am not the first person who has ever told you that the math vocabulary for a math instruction is oftentimes pretty much limited to use in that class period. You know, I don't know about you, but I don't regularly walk around using the word hypotenuse, but yet that's one of our math vocabulary words at certain grade levels. And so when we have kids discuss about math and discuss what they see and what they wonder, when we have the opportunity to help them really define their speech and their discussion by using specific math vocabulary, absolutely, that's when we have that teaching moment and we have them use that specific word. We're going to use area. We're going to use the word perimeter. We're going to use the word numerator and denominator, right? That's part of being able to fully communicate your math ideas and your math thoughts. So again, with notice and wonder, plays in very beautifully with that, math practice number 6, right? We're going to have them practice in discussions using those math vocabularies. So in tier 1, the whole group open style discussion, you can use notice and wonder, and you can even use notice and wonder in what MTSS would refer to as a tier 2. I can use the same strategy with a small group of kids. The only difference is now my questioning to them and helping them to observe what's happening in a problem or in a picture that a word problem is associated with. My questioning is going to be a little bit more targeted towards the process that I want them to discover a bit in the task itself. So again, tier 1 is going to be open-ended, and we're going to have a lot of questioning and a lot of observations. And in tier 2, I'm going to know pretty much where I need to help guide these kids in their thinking. So notice and wonder, it is a technique created by Annie Fetter. And Annie, right there on the slide, a founding member of the Math Forum, which is a great website for resources. And I like her quote. You know, Annie talks about that she is focused on helping teachers incorporate more sense-making opportunities in their classrooms so that math becomes something students think about and understand rather than something they finish as quickly as possible. Now, my guess is some of you may be in that category where in math class, you just wanted to finish as soon as possible because that meant it was over. I can talk for myself. That was definitely me. And, you know, sense making was not in the picture. And we were pretty much given the problems, given the solutions, and then we practiced and we handed in. And I just wanted to get done as quickly as possible and move on to another class that I was more successful in, because quite honestly, I never felt I understood math. That's because contextually, math was not instructed for me to know that. We were instructed on algorithms and how to do the step-by-step process. So I think Annie is a great math teacher. I would have loved to have Annie as my own teacher. So this is why I kind of like notice and wonder. So let's play around a little bit with the notice and wonder technique. So I'm going to show you a slide. And I would just put this up on the board or up on the projector. Now you can put it up on your Zoom, right, with a shared screen. And there's numbers there, there's images, that's an image. And I would just let you notice about it. Maybe take 48 seconds and just look at the picture. What do you notice? So I'm going to let you do that while I bring the camera down. So don't look at me, look at the image of the rectangle. All right, so if you were looking at the image, I might ask you as a class, what did you notice? Tell me about things that you see on that picture. I'm not asking you to solve any problems. You don't even have a problem really to solve yet. I'm not asking you about any relationships. I'm not asking you anything really specific. I'm just saying to you, what do you notice? And some of you might come up with, well, I noticed that the measurements are in inches. Some of you may come up with, there's a sink. The part of notice and wonder that you want to think about is that you want to validate whatever they are saying. So I'm going to write down sink. It's not coming up really well on the DocCam. I'm going to write down measure in inches. Okay, let me see if I can, there we go. So I'm just going to write down what the kids are saying to me. It's always important. I'm going to turn this around a little bit. Ooh, there we go. So I think it's always important to remember that when we're asking kids to have any kind of discussion or any kind of input, we have to validate that some way, somehow. If it's typing into a chat room, everything that you're hearing, maybe you've sent them out to a Padlet, right? So they can type down their responses and they can see it posted online. Maybe you're using a whiteboard in a Zoom room. Maybe you're just using your projector or your whiteboard in your classroom and it's being videotaped. You know, whatever you do, remember, one of the key successes to notice and wonder in any kind of discussion you have in any content area is when those kids give you input, you have to validate it somehow. If you want those responses to keep growing, they have to see that the effort they put into it is being honored by you by writing it down somewhere and having them being able to see what they said means something. And so let me go to the next slide because Annie Fetter did this example. And this is what kids came up with. Two sides are equal. One side is 28 inches. One side is 42. I love number 4. Your lines aren't very straight. right? That's a given. That's a given. Now, in the very beginning, when you first start doing this strategy, you are going to get non-math wonder or no, non-math notices, right? The lines aren't very straight. Well, in math, sometimes that's very important. It may not be for this problem, right? Because it's generally a quick representation of what we want those kids to do. And to be honest with you, sometimes we draw like that on the board, right? Our lines aren't very straight. In math, we have to be careful sometimes about how we draw an example on the board to make sure that it is an accurate representation of what the process is we want the kids to see. That being said, we can go on. The sink is a rectangle. It used to be a square. So as Annie, you can see in the video that I will give you the link to, Annie questions that, like, tell me more about that. If you get one of those answers that you think there's a lot of other math information underneath it, you are more than able to say to them, tell me more about that answer. The trick to doing notice and wonder, though, is number one is validate all the responses somewhere by writing them down. But number two is also that when they give you an answer, right, you don't judge it. And so if they say to you, oh, the word sink doesn't make sense because I don't think that word should be there, or the lines aren't straight, you don't say to them something like, well, that has nothing to do with the problem. What about the math? And no. In the very beginning, you want to accept all answers. And the toughest thing teachers have to do is learn how to not say to someone, hey, good answer, right? You want to do a very neutral, almost poker face response to them, right? Thank you for sharing. Thank you for sharing. Not even that's interesting. Right? Let all those value judgments go. You want to create a very safe environment for kids to express what they notice, right? And if they start to hear that you're starting to put some value judgments on other kids' notices, you're going to miss some of those kids. They're going to start to shut down a little bit. So you got to trust the process, man. I've done this enough in classrooms to know the first couple of times you do it, right? You are going to get some non-math notices. You just are. But after you have gone through this whole process, kids are going to understand very quickly what you're looking for. And maybe they don't, right? Maybe there are some kids in that classroom who their only opportunity to make a connection with you is to tell you something that they notice. You have to honor that, right? You don't want them to shut down, especially in math class. So other things they talked about was the short side of the sink is 18 inches. Again, tell me more about that. The long side of the sink is 32. You can find the area of the whole thing by making it in two pieces, right? I'm not going to tell you the class that this was done in. I'm going to let Annie explain that to you in her video that, again, I'm going to give you the link to. But so please watch that. But it's interesting, the classroom versus what they came up with. If you look at those comments, that's good math thinking. All right, there was some lots of good math thinking in that classroom that, given a worksheet and some just rote practice, you would never have come up with. So this is Annie Fetter, and the URL that I made for you is at the bottom there. It is tinyurl.com/Annie17. So URL, the tiny URL is nice because you can make several. You can make a very long URL very short and easy to remember. So there's just tinyurl/Annie17, and her video is about 5 minutes and 15 seconds long. Just to reemphasize again, the most difficult part of this whole notice and wonder routine is to refrain from value-added teacher responses, right? The only way to innovate and get those kids creatively thinking is to withhold judgment. So practice that. It is very tough to do. I did this for an in-service with the district, and didn't I, about the fourth comment in, say, hey, that was a good thought. Right away, I kind of ruined my own rule, right? So it's okay, it happens. Don't beat yourself up when you do a value judgment, but, kind of keep in your mind your awareness that you got to kind of hold the brakes on those as you go. So let's try a few. We did one with area and perimeter and the sink and the not straight lines. So looking at your screen, here's one I did with a 7th and 8th grade classroom. They were venturing into the concept of scale. And so what we did was we took all the noticeable math information out and we just started with, tell me what you see, right? And they came up with, there's people there, you know, it's a blue sky, the green grass. And then they came up with, it's an Eiffel Tower. And then they started to have the thinkings, right? That's the actual Eiffel Tower. The picture on the right is a graphic image of the Eiffel Tower. Now, if you look real close, and I didn't see this when I first put them on the board, I had one girl say to me, well, on the real Eiffel Tower, the first grill is different than the drawing on the right-hand side. And she's absolutely correct. She was absolutely right that the grill on the left-hand picture, the actual Eiffel Tower, is different than what she did not know was the scale drawing on the right-hand side. And so as time went on and different kids spoke up, we started to ask them, what would you need? What more would you need? What do you wonder? Right? And eventually we got all the information on the board to them. Now their job was to create a definition of what scale meant. Eventually we did have the question, well, in order to understand scale, well, I have to know how tall the Eiffel Tower, the actual Eiffel Tower is. And so that's when we would show them the Eiffel Tower was 324 meters. So you can see what you do is you start basic and very open-ended, and then you start to reveal information, if it's there, that the kids are wondering about. So that's the second component. This is what I notice. And now with all my notices, I'm left with some questions. And so here is what I wonder. And it might be, wonder why the grill is different from the actual Eiffel Tower to the scaled drawing. We don't know that. We can look that up. You know, what are some other wonderings that we have? Well, how much is that scaled drawing worth? You know, how much is one unit of measure in the scaled drawing compared to the actual Eiffel Tower? And then we can have those discussions. The point is, though, with notice and wonder, I love this. Point number 3, everyone has access to information and sharing information. Even the kids who most struggled in that math class were paying attention and involved with the math discussion. So again, anything you can do that holds all kids or the majority of the kids in the classroom, it's worth looking into and worth trying. I've done this in a couple 7th and 8th classrooms, and I've had some of my 7th and 8th grade teachers do it, and they reported some great successes. You know, really that the kids, even in the back of the room, right, were engaged with what was happening in the front of the room. So I wholeheartedly support the strategy. Here's another one for kindergarten and first grades. I think this is too much fun. Yeah, I just show the picture on the board, right? Or I have it in my bulletin board, or maybe it's an image from my Zoom class, and I just say, what do you notice? So look at that. What do you notice about the picture? Let's see what a few notices were from kindergarten and first grade kids. Now, teacher may have helped to transcribe some of these Post-its, right? I love the one where they figure out, you know, there's 10 green gumballs, right? They started to categorize. Isn't that not a great math characteristic to have, that we're going to group like items? But check this out too. They figured out from the price listed on the picture that 4 gumballs would cost them $1. So imagine what kind of math is kind of floating around, hidden in your classrooms, that you're not pulling out if you don't do maybe a notice and wonder activity. Like, let them tell you what the math is that they know. From that quarter, that 4 gumballs equals $1, I can spin off into money. I can spin off into quarters. I could even ask questions. Well, what happens if I want 6 gumballs? Right? Let's see how far this class can go. It's amazing what they know that we do not know they know. If you want to look at more, this was a site called, actually it's Family Math Night. Excuse me, how to do math night with your kids in schools. I would question whether or not we could even do that digitally. If you're ever interested in trying a digital math night for families, you let me know. I think there's some intriguing things we could do. Anyway, it's tinyurl.com/notice17, and it will give you a lot of examples that they used with poster paper. Here are some of my favorites, like just the target practice, and you could put little arrows in if you want to make it a little bit more fun. And it's 10, 8, 6, and 4 are the rings. And then there's a couple where the darts were. What do you notice and what do you wonder? Yeah, it's just fun to think about what kids will come up with. I like the hexagonal Venn diagram. I think that's so cool. Like they're actually saying to the kids, do you notice any patterns here? Like what makes that center circle? How often have you put a Venn diagram on the board and just listed what the categories were? Well, this goes the other way around. This gives you the whole Venn diagram, but you have to figure out what the categories are thinking about math. So it's a whole different inverse of how we're usually teaching math. And then the last one, what do you notice? So now they've used three circles, right? Another type of Venn diagram, and now they use geometric shapes. So you look at that one and you try to figure out how were the shapes categorized to get the triangle that's red in the center, right? That's a little bit trickier. You have to really do some thinking and some sorting to figure out what the rules are to get those categories into the specific circles. So again, that is tinyurl.com/notice17. So I'm going to, again, you watch the slide. I'm going to move my camera a little bit. And that was our notice and wonder from before when we did the area and perimeter. Here's another notice and wonder for you. I like this one. Oops, let me get that lined up. There you go. And so let's just say I put that on the board. So we're watching the camera now. And I could say to you, what do you notice? And you would tell me exactly what you see. And then I might ask you, well, what do you wonder? And at the same time, I'm writing these things on the board because someone might say, when I did this in the classroom, someone said, oh, it's a bar graph. I'm like, well, what you wonder is it a bar graph? Okay, so we change it back into a question. So I'm going to slowly start to reveal more math information. And as I do that, your notices will change and so will your wonderments. So let's reveal more. So what does that now tell you? What do you now notice? We have Kit Kat, Hershey's, M&M, and Reese's. What might that mean? What are your wonderments? Let's reveal some more. Someone always says, it looks like there's a piece missing. Or I wonder why there's a space there. Because it's my favorite, Snickers. Yes, let's bring in those Snickers, man. So now we have a range of what looks like to be candies. What might you wonder now? And so we're going to keep revealing. Oh, every bar graph has a title. And so this is Trick or Treat, America's top selling candy in 2013. And here we have a range of values. And so now one of the wonderments might be, what do the values represent? When I did this in an in-service, the teachers were wondering, is this money or is this number of pieces? Perhaps it's a giant bowl of candy, right? And there is about 500 Reese's in the bowl. Maybe there is about 500 M&Ms. Maybe there's about 400 Snickers. So we still need to know the value. And lo and behold, we figure out it is dollar value. But we're not quite finished yet. It is sales in millions. So that is 100 million, 200 million. Now, I present to you this question. This is what I wonder. If you went through this process, how engaged would kids be now in answering any questions that the textbook might have about this specific graph? See, sometimes in math, we take away the fun of investigating the problem. We also take away the ability to make context out of this whole image and this problem. right? We've led them by layer and layer to understand what that problem might be representing. Now, given another example of a bar graph, the same kind of revealing of information, I feel pretty confident in reading any bar graph, which is a lot different than me getting the information straight from the book, right out the gate, and then have the questions to answer. So that was our little experiment there. What else can we use Notice and Wonder for? Let me get this ready. Here we go. We can use it to help them discern what the rules might be. So I would start off with just this and ask them, what do you notice? And I'm going to come up with probably there's question mark, or I'm sorry, question mark's not even there, that there's addition signs, there's an X, there's two X's, there's a 3, there's a 7, there's parentheses, and then it might be, what do you wonder? Why we're even doing this is going to be one. I would write that right on the board, right? And someone might come up with, does this have anything to do with the order of operations? Or I wonder if we have to do parentheses first, right? So you're going to kind of peel back what their prior knowledge is. And I'd be like, okay, and I would write everything on the board, what they noticed and what they wondered. Now I would reveal a second part. And now in thinking, right, we have to have understanding of relationships. So what is the relationship from line 1 to line 2, from step 1 to step 2? What has changed? What do you notice that has happened to that expression in line 1 to the expression in line 2? Tell me about what exactly you notice. And then the kids are going to come up with what they notice. And now I'll reveal the next one. How did I get from line 2 to line 3? How did I get from the second expression to the third one? What did I do? What do you notice? And in this way, we are revealing to them the process. And then I have the final, the final answer. And what did I do to get that final answer, that final solution there? We're hoping that they see that in order to get 10x, correct, I joined 7x and 3x. And what did I notice about that? Well, they both have x. Yes, we're going to combine like terms. So now when I start to talk to them about distribution, combining like terms, it may make more sense because I've concretely gave them a visual example of what it looks like, and then I attach the vocabulary word. Too often times we throw out the vocabulary word in the definition without allowing them to actually contextually see what the process is that makes up that vocabulary word. And so now I can do this, right? I've gone through this, maybe I've gone through a second example the same way. And now I'm going to show them, I'm going to show them that. And now I'm going to say, with the rules that we think we understand, right? With the wonderments that we have, let's put the wonderments to a test. We're going to do a proof. And so knowing what we think we know from what we noticed and wondered, what would be my first step, right? And we can reveal what that next step would look like. And we can ask them using the patterns that we discussed, right? Look at the board, look at what we have wondered, look at what we're trying to put into effect. We can go through and start to put into play what we wondered. So we moved from just noticing, we went to wonderment, and now in math, we went to a proof. Let's see if this actually falls or gets everything into place. So again, notice and wonder. Let me turn myself around there a little bit for you. Whoop. There we go. Hi. So notice and wonder, again, it's a great way to help kids get into a math discussion. It's a great way to show definition. It's a great way to show an algorithm. It's a great way to show properties of math. So whatever might have a pattern, we can use our vocabulary words. We can look for reasoning and structure. It's just a great activity. And, you know, I've done this in second grades up through, like I said, seventh and eighth grades. And once the kids get the hang of it, especially when they know that it's a very low risk, low humiliation task, right? You're going to find you have discussions just abounding in your classroom. And you know what? Teachers, you're going to like this too. How often have you put something on the board and you ask for a discussion and it kind of falls? You know, we've all been there, man. Those are the longest seconds ever, especially if you're being observed, right? But guaranteed this way, you get those kids just start out a little bit, you nudge them a little bit with what do you notice? You're going to have discussions abounding in that classroom and you're going to have a great time doing it. So let's review some of the websites that I gave to you and I would suggest you look at. The first one is a new one for you. It is tinyurl.com/noticewonder17. That is the National Council of Teaching and Mathematics, and they have a whole protocol about how to, excuse me, how to do notice and wonder in your classroom. It's a great resource because it will walk you right through it. The second one is the Annie 17, and that is the video of Annie Fetter. Once again, talking about notice and wonder. And the last one is the tinyurl.com/notice17. And that is the website which will give you those posters of the notice and wonder images and activities for that family math night. But you can use them in your classroom. So with that being said, we are going to close down for right now. Remember that it's reasonable guidance that when we say, let's look at tier 1 instruction and really make sure that's solid and that we're trying to explore different ways of instruction that work best for kids, and that's good guidance because that tiers 2 and tier 3 are really dependent about how strong our tier 1 is. Try out the low prep strategy of notice and wonder. I so believe that you're gonna have a good time with it, the kids are gonna have a good time with it, and we're gonna start to blend, right? The procedural knowledge with conceptual knowledge with one activity. So give it a try. And remember of all things, you know, it allows kids to participate at all levels in that math instruction and that math engagement. So again, I love the activity. I hope you do too. So in closing, again, thank you very much. We are the Learning Hub at BLAST. And if you have any questions, feel free to email the Learning Hub